In this video, we are going to discuss about image processing in opencv, and then we are going to plot a histogram of an image. So firstly, I have imported a few libraries. You can see NumPy as NP, Pandas as PD, CV2 as CV, and also for using Google Colab patches import for ImShow for displaying an image in Google Colab, we have imported from Colab patches. Two new libraries here you can see, that is skimage import IO and PIL import image. These two libraries, firstly, skimage is a collection of algorithms for image processing and computer vision. And PIL, we all know that it is Python image library for image processing. And import matplotlib.pylab as PLT for plotting. So these are the libraries which we have imported. And next, now we are going to read image from an URL. Earlier what we used to do, we used to import or upload a particular image which you have downloaded and then used to process it. But now we are going to use a URL to process an image. And here you can see that from skimage we have imported IO. Now with the help of IO, we have read this particular URL in which the image is stored, or we can say the location of the image. So that we have read in the variable name image. And in image 2, we have changed the color. That means the original image color is changed from BGR to RGB. That means we have changed the color components. And that we have stored in the final frame. And the final frame is actually the concatenation, or we can say both the images are concatenated, image and image 2, and then the final frame has display. So when I execute this particular cell, here you can see that both the images are actually concatenated in a form. So this is the original image of the bird. You can see the blue bird here. And this after we have changed the color mode from BGR to RGB. Here you can see that. After changing the color mode, we have displayed that as image 2. And this we have displayed with the help of ImShow function of CV2. And the name is final frame. So this is the final frame that has been displayed after the color has been changed with the help of the hconcat that we have used for concatenating both the frames. Next, if I want to print the image type, shape and size, then I can do simply, I can write in the print statement image.dtype, image.shape and image.size for calculating the original image which is there, not the image generated after changing the color. So for that you have to simply write like this, and when I execute this particular cell, here you can see that the image dtype is uint8, the image shape is 443 into 590 into 3, so that is actually the width, the height and the color component of the original image, that is RGB, and the multiplication of op give us the size of the image, that is the combined multiplication of width, height and the color, gives us 7,84,110. So that is the actual size of the image for the multiplication of the width, height and the color component. Next, what we are going to do, we are going to generate the histogram, or we can say the frequency of a pixel. So for that we have just taken the import numpy as np, and then we have plotted a two-dimensional array, we can say a 2D array with the help of np.array, and these are the values which have been given. We have printed the array also. Now here we have used two functions, print a.ravel and a.flatten. Now the use of ravel function is actually numpy module to change a particular two-dimensional array into contiguous flattened array, we can say a 1D array. So both the function do the same work, but here I have implemented both so that we can see it. So ravel and flatten do the same task. They are actually used for converting a two-dimensional array into a 1D array. Then I have plotted the histogram with the help of matplotlib, which we discussed, plt.hist, a.ravel, we have mentioned the beans. Now what is actually beans? Beans are actually shows the number of pixel for every pixel value that ranges from, we can say 0 to 255 for any color range we can say, but here we have just given simple beans range, that is 50, and the range we have given 0 to 50. That means we are just plotting actually a histogram frequency for the pixels of the array which we have given. We are considering that array is this only, but we know that an image array has more pixels, which we have seen in the original image also. So when I do that and execute this particular cell, so here you can see that this is how a 2D array is generated with the help of np.array which we have made. This is the two-dimensional array, and here you can see the conversion that is done with the help of ravel and the flatten function which is there. It has actually converted the 2D array into one-dimensional array, not changing the values, just changing the dimension. And next you can see here that it has plotted the histogram also with the help of beans and the range which you have given. So here you can see that the value of 1, it comes only one time in a particular array, so it has plotted like this. Next 2, it comes 3 times, so it ranges up to here. You can see the value of 2 ranges like this, and similarly for 10 it comes in the value and the histogram is plotted. So actually there in this axis there are the pixel value we can say, and this is the frequency. The y-axis is actually the frequency, that how many times that particular pixel value is generated. Next here we are going to discuss the same for the image we have. For this blue image of the bird which we used to have, now we are going to plot the histogram for it. So what we have done, we have simply written plt.hist for plotting, image.ravel. Here we used A as the name of array. Now we use the image. Beans we have given up to 256 and range is also 0 to 256, and plt.show to display the histogram which is plotted. As I execute this particular cell, here you can see that a histogram is plotted. Now as that image has lots of color components, so that's why you can see a histogram like this, because it has several components of every pixel value and the frequency will increase because it is a colored image. That's why we get such a histogram. Next, if I want to generate with the help of color, that I don't want such a histogram, I want to generate actual plot with the help of the colors which are there, that is blue, green and red. So for that, here you can see we have mentioned the colors, those are blue, green and red, symbolizing BGR. And for I and column, a color in enumerate color. Now what is the use of enumerate? We know that enumerate is also a Python function, and it is to add counter to the iterating variable. To every iterating variable it adds a counter. So with that we have used here the calhist function. Now what does this do? It is used for histogram calculation in opencv. We use cv2.calhist also, and here also we have used for cv2.calhist for plotting the histogram. First parameter, you have to give the image, or you can say it is the source of image which is there that you have to give, so that we have given in the square bracket. Next, we have given the channels which is there. It also can be given in square brackets, so we have given that. It is actually the index of a channel for which we calculate the histogram. For example, we can say if the input is a grayscale image, then the value has to be 0. For any colored image, you can pass 0, 1 or 2 to calculate histogram of blue, green and red channel respectively. But that we have executed a loop, so where we have given the counter variable I only. Next here, none. This none actually is used to denote the mask image. Now to define a histogram for a full image, it is given as none, that you have to draw a histogram for the complete image. But if you want to define the histogram for a particular region of the image, then you have to create a mask. So that we are not doing here. So that's why we have given here none, that we want a histogram for the complete image of the bird. Next, we have given here the hist size, that is the represent the beans count which is there, and it also needs to be given in the square brackets. And next we have given the range which is there, the range of the colors we can say, that is normally it is 0 to 256. So when we do that and execute this particular cell, so here you can see that now the histogram is actually plotted according to the colors. You can see red, blue and green, the colors which you have given. According to that, a plotting is done. And we have used plt.show to display it. Next we have, now if I want to convert this particular image, the image which we have of the bird is actually in BGR, we can say a colored image. Now if we want to convert it, then we simply use a variable. Here we have used gray image equals to cv.cvt color, image, the original image which is there, and then what you want to convert it. So we have used here cv.color BGR to gray. That means we want to convert the color image into a gray image, and then we have displayed. So when I execute this particular cell, here you will see that the colored image of the bird is now actually in black and white. And next what we have done, we have plotted that black and white image and histogram of that. So what we have done here, gray image.ravel we have given. Ravel function is used actually in NumPy module to change the 2D array. So obviously this will be also 2D array, every pixel that will be in X and Y axis of this particular image. Then we have given the beans and similarly the range. We have used the show. Now here I have used the size and shape also, so that I can show you that the size and shape is actually reduced when an image from colored is changed to grayscale. Why? Because the color component is reduced. So obviously the size and shape of the image is to be reduced. So when I execute this particular cell, Here you can see that this is the histogram plotted. Now this is quite different. Here you can see this histogram of the colored image and the histogram which is there of the grayscale image. Both are different because why? The color component has reduced and also the size of the image is reduced. Here you can see the size of image now, it is also reduced. Now it is only 2,61,370, and here you can also see the shape, that is 443 into 590. That is there, but here we do not see any color component which we used to see in the colored images, that it shows us 3 for BGR. But now it is not displaying any such. Why? Because it is a grayscale image. So that's why we can see the histogram is a bit different. Now here you can see the intensity of the pixels which are there according to the pixel values, that wherever it has detected a dark spot, or we can say the black or 0, so it has detected those spots, and for lights also, or we can say for white also, it has generated a histogram like that. So this is all about image processing in opencv and how can you plot a histogram. Firstly, what we have done, we have imported the libraries, then we have read an image with the help of URL and converted that image also, that means BGR to RBG, and then concatenated both the image with the help of hconcat function and displayed that in the final frame. Next, we have printed the size of the image and the shape of the image that is there. Just because of the color component, you can see the size here is greater and there it is less. Otherwise, the shape is actually same only of both the images, that is of black and white and colored image, you can say, that is 443 and 590 here for black and white also, and here you can see for colored also it is 443 and 590. This 3 is actually generating the color component which is there. In grayscale it is 0. So next we can see the histogram frequency of pixel which we have generated as a numpy array. Firstly, I have shown you the numpy array so that we can understand the ravel and the flatten function. Both the functions are used for converting a 2D array into a contiguous flattened array, or we can say 1D array. Then we have plotted a histogram for the colored image. Then we have used the enumerate function and then actually printed the red, blue and green, all the colors which are there, we have plotted them. And lastly, what we have done, we have converted that image into a grayscale image and then printed or displayed a histogram with the help of it and checked the shape and size of that image. Firstly, we check the size and then the shape of image. So this is about image processing in opencv and then plotting a histogram with the help of it.